Hello everyone, here we are going to start with exercise 9b of the chapter triangle, which is based on congruency of triangles. Now let's see question number 1. Now here in question number 1 we have been given with the triangle ABC and we are having two equilateral triangles, that is on AC and AB. On AC we are having AEC and on AB we are having ADB, and we have to show that CAD is equals to angle BAE. For that we know that this is an equilateral triangle, so this will be of 60 degree. Similarly, this is also of equilateral triangle, so this will be of 60 degree. So here we can write this one as angle DAB equals to angle EAC 60 degree each, and they are interior angles of equilateral triangle. Now we can add this common portion in both of it, and this will become angle DAB plus angle BAC equals to angle EAC plus angle BAC, and on adding DAB with BAC we get angle CAD equals to angle EAC plus BAC will be angle BAE. That is to be proved for the first part. The next part we have to prove that CD equals to BE. For that we are going to prove the triangle CAD congruent to EAB. So in triangle CAD and triangle EAB, here CA is equals to EA. At the sides of equilateral triangle. Then we have AD equals to AB. Again the sides of equilateral triangle. Now we can take CAD equals to EAB, which we have proved over here. So CAD equals to EAB proved above, and therefore triangle CAD is congruent to triangle EAB by, we have used this side, this angle, then this side. So SAS. And we have to prove that CD equals to BE, and that will be by CPCT. So CD equals to BE by CPCT. Hence proved. Now let's see question number 2. Here in this question we are having a square ABCD and a equilateral triangle ABP. So we know that equilateral triangle has equal sides and square also have a equal side. So we have all these having the equal sides. Now as we all know that in an equilateral triangle this is of 60 degree, and in a case of square this is 90 degree. So with the help of these two we can find the value of this one, and similarly we can do in this side too. Now the very first thing which we have to prove is we have to show that this triangle is congruent to this one. So for that we can use this side equals to this one and this side equals to this one. Now we need the third parameter to prove these two triangles congruent. We can't use these side because we aren't having any relation for them. So we'll switch to these angles. So let's see the values of these angles. So in case of this one, the angle DAP equals to angle DAB minus angle PAB, and here DAB is 90 degree as the interior angle of square minus 60 degree as the interior angle of equilateral triangle. So this is equals to 30 degree, and similarly over here too angle CBP equals to 30 degree. So we have both of these two angles as 30 degree each. Now we can start with the triangles. So in triangle APD and BPC, now we can use AD equals to BC at the sides of square. Then we can use AP equals to BP as the sides of equilateral triangle. Then we can use angle DAP equals to CBP as 30 degree each. Now to prove these two triangles congruent, we have used this side, this angle and this side. So it is SAS. Therefore triangle APD is congruent to triangle BPC by SAS. Now, as these two triangles are congruent, therefore this side will be equals to this one by CPCT. So we get DP equals to CP as CPCT. Now we have to find this angle, that is DPC. For that, first of all, we are going to find the value of this angle. Now we know that this one is 30 degree, and we very well know that this side is equals to this one. And as these two sides are equal, this angle will be equals to this one. So let these two angles as x each. Now with the help of the angle sum property of triangle, we can find the value of x. Therefore, in triangle ADP, x plus 30 equals to 180. So 2x equals to 180 minus 30. That is equals to 150. So x will be equals to 75. So the value of this angle is 75 degree. So with the help of this 75, we can find the value of this one, as this whole is of 90 degree. So angle PDC equals to angle ADC minus angle ADP. So ADC we are having as 90 degree, which is the vertex angle of square, minus ADP, we have just calculated the value of x, that is 75. So this one is of 15 degree. Now as DP equals to CP, therefore this angle will be equals to this one, as the angles opposite to equal side. Therefore we are having angle PCD equals to angle PDC, angles opposite to equal sides. Then we will having this angle also as 15 degree. Now with the help of these two angles, we can find the value of this one by using the angle sum property of triangle. So here in triangle PDC we got angle PCD plus PDC plus angle DPC equals to 180 degree. Here the value of PCD and PDC both are 15 degree. So we have got 15 degree plus 15 degree plus angle DPC equals to 180 degree. Now the angle DPC equals to 180 degree minus the sum of these two, that is 30 degree. So we are having 150 degree as the answer for this question. Now in question number 3, we are having a right triangle, that is ABC, and then on the side AB we are having a square, that is AQPB, and on the hypotenuse again we are having a square, that is ASRC. So all of these sides will be equal. Similarly, all of these sides will also be equal. Now we have to prove the triangle ACQ congruent to triangle ASB. And to prove these two triangles congruent, we are having AB equals to AQ, the sides of a same square. Then AS equals to AC, the sides of the same square. But we need one more parameter. So we are going to just equate these two angles equal, that is angle CAQ and angle this SAB. So as we know that this angle and this angle both are 90 degree, and this common portion, this middle one, is common to both, and if we add this common portion in both of the angle, then the whole will become equal. So let's start with it. Angle QAB equals to angle SAC, that is 90 degree each, as they both are the vertex angle of square. Now we are going to add the common portion BAC in both of the sides. So angle QAB plus angle BAC. This will be SAC plus angle BAC. Now on adding QAB with BAC, this will become QAC. So angle QAC equals to this SAC and BAC will become BAS. So here we get angle BAS. Now we have to prove the triangles ACQ congruent to triangle ASB. So in triangle ACQ and triangle ASB, AC equals to AS, AC equals to AS, the sides of same square. Similarly, AQ will be equals to AB, sides of same square. Then we have proved QAC equals to BAS. So QAC will be equals to angle BAS, proved above. Now to prove these two triangles congruent, we have used this side, and this angle. So it is SAS. Therefore, triangle ACQ is congruent to triangle ASB by SAS. And we have to show that CQ equals to BS. This can be proved by CPCT. So CQ equals to BS CPCT. Hence proved. Here in question number 4, we are having a triangle ABC and this BD is median which is produced to E such that this BD equals to DE, and as this BD is median, therefore AD is also equals to CD. Now we have to prove that this AE is parallel to BC. Now for this we are going to prove these two triangles congruent. So in triangle ADE and triangle CDB, this AD equals to CD as A is median, and this BD will be equals to ED given to us. Then angle ADE equals to angle EDB, vertically opposite angles. Now to prove these two triangles congruent, we have used this side, this angle, and then this side. So it is SAS. Now after proving these two triangles congruent by using the property of SAS, we can prove this angle equals to this one by CPCT. And as these two angles are also interior alternate angles, therefore this will become parallel to this one. Now let's number these angles as 1 and 2 respectively. So angle 1 equals to angle 2 by CPCT. And as these angles are also interior alternate angles, therefore this AE is parallel to BC. Hence proved. Now here in question number 5, we have been given with this figure, that is PQR. Now in this one, we are having two bisectors, that is XQ and XR, which bisects the angle Q and R respectively. And we are also having two perpendiculars from X, that is XT and XS, on the sides PQ and QR respectively. Now very first of all, we have to prove the triangles XTQ congruent to triangle XSQ. So in triangle XTQ and XSQ, we are having the angle XTQ equals to angle XSQ. So angle XTQ equals to angle XSQ, 90 degree each. Then this angle is also equals to this one. So XQT equals to angle XQS, as XQ bisects angle Q. Then after that, we have this side XQ common in both of the triangles. So XQ equals to XQ common. Now we have proved these two triangles congruent with the help of this angle, and this side. So it is AAS. Therefore triangle XTQ is congruent to XSQ by AAS. Now to prove these two angles equal, we have to draw a perpendicular from here as XU. After that, we have to prove these two triangles congruent. Now, while to prove these two triangles congruent, we will be having this one as common side, that is PX, and this angle will be equals to this one, as they both are of 90 degree each. Now we need one more side to be proved. So we can use this side equals to this one, but it is not proved yet. So first of all, we have to prove these two sides equal. For that, we are going to prove these two sides equal with the help of the CPCT in this triangle. So XT equals to XS by CPCT. And similarly, this side is also equals to this one. Similarly, XU equals to XS. Now let this one be equation number 1 and this one be equation number 2. So from equation 1 and 2, we get XT equals to XU. Now we'll be proving these two triangles congruent. So in triangle XTP and XUP, here we have already proved that XT equals to XU, then PX equals to PX common, and angle XTP equals to angle XUP, 90 degree each. Now to prove these two triangles congruent, we have used this 90 degree, this side that is hypotenuse, and one of the side over here. So it is RHS. Therefore, XTP is congruent to triangle XUP by RHS. Now we can prove these two angles equal by CPCT. That is, angle TPX equals to UPX by CPCT. Therefore, this PX bisect this angle P. Hence proved. Now here in question number 6, we have a parallelogram ABCD such that angle A and C are obtuse angle, and on the diagonal BD we have taken 2 points X and Y such that this angle XAB and YCD, they both are right angled over here. Now we have to prove this AX equals to CY. Now to prove these two sides equal, we are going to prove these two triangles congruent. So in triangle XAB and YCD, we are having the angle XAB and YCD as 90 degree each. So angle XAB equals to angle YCD 90 degree each. Then we are having this side, this equals to this one as opposite sides of a parallelogram. So AB equals to CD, opposite sides of parallelogram. Now we know that in the parallelogram we have the opposite sides as parallel to each other. So we can use this angle equals to this one as interior alternate angles. Let name the angles as 1 and 2 respectively. So angle 1 equals to angle 2 by interior alternate angles. Now to prove these two triangles congruent, we have used this angle, and this side. So it is ASA. Therefore, XAB is congruent to YCD by ASA. Now we can prove these two sides equal by CPCT. So AX equals to CY by CPCT. Hence proved. Now here in question number 7, we are having a parallelogram ABCD. And here this AB is extended to E such that this AB is equals to BE. And similarly, AD is extended to F such that this AD is equals to DF. Now as we all know, the opposite sides of a parallelogram are equal, so this will be equals to this one also, and similarly this will be equals to this one. Now we have to prove the triangle BEC is congruent to triangle DCF. Now we can see that this side is equals to this one and this is equals to this one. Therefore, this side will be equals to this one. Similarly, this is equals to this and this side is equals to this one. So this side will also be equals to this one. Now we are having the sides, but now to prove the third parameter, we can't use this side as nothing has been given for us. So we are going to use this angle equals to this one as the corresponding angle. Similarly, this angle is also equals to this one as corresponding angle. Now as this angle is equals to this and this is also equals to this one. Therefore, this angle EBC will be equals to angle CDF. Now first of all, we have to show all of this equal, then we are going to use in the triangle. Here angle EBC equals to angle A by corresponding angles. Also angle CDF equals to A by corresponding angles. Now from above these two, we can conclude that this angle equals to this one. Therefore, angle EBC equals to angle CDF. Now AD equals to DF given to us and AD equals to BC, opposite sides of parallelogram. Now from above these two, we can conclude that DF equals to BC. Now as we have proved this DF equals to BC, similarly we can prove this EB equals to CD. So similarly, now we can prove these two triangles congruent to each other. So in triangle EBC and DCF, EB equals to CD proved above. Then BC equals to DF again proved above. And at last this angle equals to this one proved above. So angle EBC equals to angle EDF. Now to prove these two triangles congruent, we have used this side, this angle, then this side. So it is SAS. Therefore, the triangle EBC is congruent to triangle DCF by SAS criteria. It's proved. That's all in this video. Thank you.